Hello everyone. So, can any one of you confirm whether I'm audible?
Yes, ma'am.
Yeah, good. So, welcome to phase two GATE live mentoring session of that is conducted by NPTL. So, okay. So, we are going to start today's session by solving three problems, majorly on networks and controls today. So, let me share my screen. So I guess all of you are going to appear in GATE 2023 exam. So I guess this kind of live mentoring sessions would be much more helpful for you guys. So let me share the screen and let's go on with the first question. Okay, so hope my screen is visible. So the first question goes like this. Okay, so yeah, so this is GATE 2015, I guess. The question. Okay. So the first question is going like this. The signum function, all know that signum function is given by this formula. That is, it takes the value 0 when it equal to 0. And if, let me write it in a broader way, signum of x is equal to 1 when x greater than 0 -1 when x less than 0 and 0 when x is equal to 0. So the graph will be coming something like this, 1, and it takes value -1, and this is signum of x. So for x greater than 0, mod x will be x. So x by x gets cancelled and we get 1. Similarly, for x less than 0, we get mod x to be minus x. So x by minus x is equal to -1. Right. So the signum function definition is like this. So they are asking what is the Fourier series expansion of signum of cos t. So they are given four options A, B, C, and D. So they are saying that only sine terms will have with all harmonics. The Fourier series expansion of signum of cos t will be having only sine terms, only cos terms with all harmonics, only sine terms with even numbered harmonics, only cos terms with odd numbered harmonics. So out of these four options, there is only one option which is correct. So work on this. I'll give you some 3 minutes time on this question. Try using your basic understanding on Fourier series into this question. Anyway, I'll be solving the problem. So get started. Just try to use the Fourier series expansion, or a simple hint is that try to visualize the graph and find whether it is half wave symmetric or how does that waveform look like. With that, I guess you can get the answers. Work on. Just a second, I'll admit all these. Please mute your mic. Oh, sorry, I got disconnected. So, okay. Okay. So let us solve that question. So, as did anyone one of you solve this question and have gotten any answer? It's okay. Put up in the chat box or okay. So it is a D. So many of you have okay. Two of you have said D. Let's check whether the answers are right or not. Okay. So if signal is even symmetric, it means that it does not contain any sign terms. BK will be zeros. But if signal is odd symmetric, it contains only sign terms. And DC will be equal to 0, not equal to 0. So if a signal is even symmetric, it is guaranteed that the DC coefficient will not be equal to 0, and it should not have any sign terms, meaning that the coefficients pKs will be 0. But if it is odd symmetric, it contains only sine terms, and the coefficients of cosine terms in the trigonometric expansion will be all zeros, and the DC component will be equal to 0. So you need to remember both of these lines, right? So till now I've discussed if the signal is even symmetric and if the signal is odd symmetric, how the Fourier series coefficients will be looking like. Meaning the coefficients will be only containing cosine terms when the signal is even symmetric, and it contains only sine terms if it is odd symmetric. Okay. I'm introducing you something called as a half-wave symmetric. So what is half-wave symmetric? Half-wave symmetric is nothing but x of t is equal to minus x of t plus t by 2. So if suppose if you're having a signal like this, say here you have a point t by 2, here you have a point minus t by 2. Here again it is t, like that. Okay. Suppose in case if you are shifting by t by 2 and reversing the amplitude, the shape should be the same like this. Right? What do you mean by shifting by t by 2? It can be either plus or minus, anything can be here. Shifting to the left, if suppose you are shifting like this, and if you are reversing the amplitude, it will be something like this. So it should be just a second. So here it is t by 2. So if you are shifting by t by 2, what happens? You will get something like this. That is minus t, 0. Now again you should reverse the amplitude. How will you reverse the amplitude? Reverse, flip it along the x-axis. So if you are flipping along the x-axis, you should see whether x of t here and minus x of t plus t by 2 are equivalent. If they are equivalent, we say it is half-wave symmetric. If they are not equivalent, then we say it is not half-wave symmetric. If it is equivalent, we say it's half-wave symmetric. If it's not equivalent, we don't call it as half-wave symmetric. Okay, this is a counter example which I have given. If suppose here, if you have t and minus t, if you're shifting by t by 2, what you will be getting? Something like, again, you can try on examples for half-wave symmetric such that this property is satisfied. I'll go on, at the end you will see an example for this half-wave symmetric. So now we need to see what this waveform signum of cos t looks like. We need to see what this waveform is, right? So usually they say even plus half wave symmetric, the Fourier series, if the waveform is even plus half wave symmetric, it means that it contains cos terms, Fourier series, coefficients. Fourier series expansion will be having cos terms with odd harmonics. Similarly, if it is odd plus HWS, the Fourier series will have sine terms with odd harmonics. So even though if it is half-wave symmetry, we won't be getting those cos terms. We will have even harmonics. We will have only odd and odd harmonics with sine, cos and sine terms. Remember like this. Since it is an even function, cos is also an even function. So even plus half-wave symmetric means whenever a signal is half-wave symmetric, we'll be getting odd harmonics. Whenever it is an even plus half-wave symmetric, we say it has cos terms only. Whenever it is odd, we say the Fourier series expansion has only sine terms, right? So what is even? Even means a signal should be obeying this property. Odd means the signal should be obeying this property. When you flip along the y-axis, they should be equal. When you flip along the y-axis and then x-axis, then also the signals should be represented the same. For example, you know odd signal, right? This is an odd signal. This is an even signal. So if you're flipping along y-axis and then flipping along x-axis, we'll be getting the same x of t signal. Similarly here, if you're flipping along the y-axis, you'll be getting the same signal. Okay, so that's what this even plus half-wave symmetric means. Half-wave symmetric means some before property should be this condition and this condition, both this condition, yeah, this and this is half-wave symmetric condition, this is even signal condition. So both should be obeyed in order for a signal to have the Fourier series expansion should be of cos terms. So this is a property which you can note it off. So now we can draw signum of cos t, which will be substitute in the formula that is given when cos t is not equal to 0, then cos t is equal to 0. So to be precise, cos t when 1 when cos t is greater than 0, cos t is less than 0, minus 1, 0 when cos t is equal to 0. You know to draw a cos t function. Assume it has a period t. So it will be something like
this, the amplitude should be same. T, this is cos t. So whenever it is greater than 0, so let me mark it by a red color. So whenever it is all greater than 0, we say it is 1. Whenever it is less than 0, we say it is minus 1. When you do this, what you will be getting? Whenever cos t is equal to 0, we will having the value 0. Similarly 0, 0, 0. So it is greater than 0, so 1, minus 1, 1. T by 2 minus t by 2. Something like this. Okay. Okay. So this signal, let us see if it obeys the half wave symmetric property. Right. This can be even x of t minus t by 2. So shift the signal by t by 2. See, this point is t by 2. We are assuming time period equal to t. So this should be t by 2, this should be minus t by 2. So now we are going to draw a signal x of t plus t by 2. Shift the signal to the left. What you will be getting? You will be getting a signal like this. Now again reverse it along the x-axis. So you will be getting something like this. So now if you are comparing, this is nothing but minus x of t plus t by 2. If you are comparing the second graph with the first green graph, they are equal. So this is what is x of t. When you are comparing with 2, 1 and 2 are equal. So that means it is half wave symmetry. And the signal is also even. Even if you are like flipping along the y-axis, the signal still remains the same. So it is even. So what I said, whenever the signal is half wave symmetric and even, the Fourier series expansion will be having cos terms with odd harmonics. Cos terms with odd harmonics. Therefore, the option is B. Is it clear with everyone? With everyone. Uh, can I get acknowledgement for this? Yeah. So is it has anyone have any doubts? Like these properties, even if a signal is even plus HWS, or if it is odd and half wave symmetric, this Fourier series expansion will contain only cos terms, and sine terms can be derived. They can be derived and they can be solved. Okay, but as of now, I'm just giving a revision and a keynote such that you can solve the problems much more easily. Let's move on to the next question. So I guess the answer is clear with everyone. Please please, I request you guys to join by 6 o'clock because I won't be able to admit you as soon as I start the class. So it will be quite a lot of interaction. So when it is interaction based, this will be kind of a disturbance for us. Sure. Sure. See, what is signum t? So signum t is nothing but it takes value 1 when t is greater than or equal to 0, and it takes the value minus 1 when t is less than 0. But here, what they have clearly given in the question is that when t is equal to 0, it takes the value 0. Right? So at this point, 0th point, at t equal to 0, signum of t takes 0. When t is greater than 0, it takes the value 1. And similarly, when t is less than 0, okay. See, the time that is given is 1 hour, so I need to handle 3 questions. So mostly I'm concentrating on the keynotes which is related to the question. I can't derive all those notes, like all those concepts whichever I'm explaining in the class. But its derivations are all simple. You can take note of the keynotes which I'm giving and go surf in the net. It will be easily understood. Or if you're having any more doubts with any of those, you can ask me in the next class. Alright. Okay. So now our aim is to draw the graph for signum of cos t. So in the formula, signum of t is equal to t by mod t when t is greater than, not equal to 0. 0 when t equal to 0, which means when t by t and t is greater than 0, t by minus t when t is less than 0, t equal to 0. Now we are in the position to draw signum of cos t, which is equal to 1 when cos t is greater than 0 and minus 1 when cos t is less than 0, 0 when cos t is equal to 0. Just in place of t, substitute cos t. Right, we know the graph of cos t. It is something like this with period t. So here it should be t by 2 minus t by 2. So something like this is the graph of cos t. So they say cos t is greater than 0. So which are the portions which are greater than 0? So this is the portion where cos t is greater than 0. And this is the portion where cos t is greater than 0. And which are the portions where cos t is equal to 0? This portion. And which are the portions where cos t is less than 0? This portion. Right. Now, plotting for signum of cos t. If cos t is greater than 0, then the value is 1. See here, cos t is greater than 0, the value is 1. When cos t is equal to 0, the value is 0. When cos t is less than 0, the value is minus 1. So something like this is repeating. T by, here it is t by 2, this is t by 4, here it is again t by 2. Right, this is the graph of signum of cos t. Understood till now? So this is the doubt you had, right? Is it clear now? Yeah, auto admit. Okay, I'll see. Yeah. Any more doubts? I don't find anything like that. Anyway, I'll check with that and get back in the next class, or I'll find an alternative to admit people. Okay, let's go on to the next question. I think my screen is shared. Yeah. So the next question goes like this. We'll solve this question first. The Navier plot of the transfer function. So they have given a transfer function g of s to be k by s square plus 2s plus 2 into s plus 2 does not encircle the point minus 1 plus j0 for some k equal to 10 and it encircles the point minus 1 plus j0 for k equal to 100. They are asking when the closed loop system is stable for k equal to 10 and stable for k equal to 100. So they have given something like this. So you need to know about the Nyquist plot in order to answer this question. See, so for a system to be stable, the closed loop poles in the right half of S plane should not be equal to, should be equal to 0, because in right half of S plane there should not be any poles present. So try this question. Use the principle of argument equation. I'll give you some
do one thing. Whenever I post a question or share the screen with the question, try screenshotting it and use it to solve the question. Because if I try to admit the people, then my question won't be visible. So shall so anyone has got any answer? See, this is using the principle of argument where you'll be dealing with those poles, zeros, and encirclements. So shall we start solving? Or you need time for solving it? It's quite simple. Once you know the principle of argument, okay, I'll give the hint for those of you who doesn't know. Let me have it in my lens. Yeah. solution. So I'll write the concept in the red color. Okay. So let P be the number of open loop poles in right hand side of S plane. Let n be the number of encirclements around -1, 0, and usually this n, when the encirclement is found to be anti-clockwise around the point -1, 0, then n is equal to positive. If n is clockwise, then n is negative. All right. So keep these in mind. And by principle of argument, POA, let me represent it as POA, principle of argument. This Z will be equal to P minus N. Z is nothing but number of closed loop poles in right half of S plane. So usually this Z should be equal to 0. Why? Because closed loop poles in right half of S plane should be equal to 0. Why they should be equal to 0? When poles are present in the right half of S plane, say suppose you have some one here, pole here. So 1 by S minus 1. What is the inverse Laplace transform of 1 by S minus 1? E power t u of t. So what is e power t u of t? E power t u of t is unstable system because it keeps on growing such that it forms an unstable. It is unbounded, hence it is unstable. The signal is unbounded, right? So the pole should not be present in the right half of S plane. So now, with this given hint, has anyone solved the question? Anyone? Okay. People are saying option B is right. Okay. Okay. So, for k equal to, we have k equal to 10. They say it does not encircle, means n is equal to 0. Alright. So we have g of s is equal to k by s square plus 2s plus 2 into s plus 2. So we need to form the Routh array. To compute the number of open loop poles in right half of S plane. So g of s is equal to k by s cube plus 4s square plus 6s plus 4. So this is the open loop transfer function. So form a Routh array. We need a characteristic equation in order to form a Routh array and find how many open loopholes are present in the right half of S plane. So this is the characteristic equation: S cube, S square, S power 1, S power 0. So 1, 6, you know to form the Routh array, right? 5, 0, 4, 0. You'll be getting something like this. There are no sign changes in the first row, first column. Therefore, which implies P is equal to 0. Therefore, Z is equal to N minus P. N is also equal to 0. P is also equal to 0. So it is equal to 0, which implies there are 0 closed loop poles in the right half of S plane. So 0 closed loop poles means the closed loop transfer function is stable. So this is stable. Whereas for k equal to 100, for k equal to 100, what is in the question? Okay, for k equal to 100, it is encircling. That's what they said, right? Okay. It is encircling for k equal to 100. Let me draw the plot something like this. See, I made a mistake here. So s cube plus 4s square plus 6s plus 4. It should be plus k, right? So what they have given in the question is the Nyquist plot of the transfer function. So this is an open loop transfer function. So usually Nyquist plots will be drawn for open loop transfer functions, right? So here the k should be there plus k. Characteristic equation is numerator plus denominator, right? So k will be here. So k should be here. Okay. So anyway, the first row will be remaining unchanged, right? For k equal to 100, for this is something called, let us call it as case 2. For k is equal to 100, okay, let us draw the polar plot for this, okay? Because we don't know the encirclements for k equal to 100. So we need to draw the polar plot in order to find how many encirclements are there for k equal to 100. So g of s is equal to k by s square plus 2s plus 2 into s plus 2. Right. Usually when there are no zeros, the plot usually starts at real axis and then it goes and ends here. Why? Because there are 3 poles. Order is 3. Here order is 0. So keep shortcut in mind. Whenever there are no zeros, the plot starts at here and it goes to 0 degree, minus 90 degree, minus 180 degree, minus 270 degree. Okay. So for order is equal to 3, for one pole, it will be giving a phase shift of minus 90 degree. For 3 poles, it will be giving a phase shift of minus 270 degree. Therefore, it ends at minus 270 degree. So whenever it is of the form like this, then Nyquist plot can be drawn like this, right? So the inverse Navier plot like should be drawn. Sorry, the polar plot is drawn like this, and the mirror image is drawn like this. So the complete picture of Navier plot is now present. Right. So this is A, this is B. Because they said that K for K equal to 100, it is encircling. Right. So from this function, draw a slanting line. Right. This is going like this. So if you're drawing a slanting line, this arrow mark is approaching. Similarly, this arrow mark is approaching. That means n is equal to -2. This is the clockwise direction, right? So n is equal to -2. Open loop transfer function, it is same. Still, we have 0 open loop poles in the right half of S. So using the principle of argument, we get 0 plus 2, which is equal to 2, which means there are 2 closed loop poles in the right half of S plane. We know that if there are 2 poles in the right half of S plane, then the system is definitely unstable. Right? So for k is equal to 100, the system is unstable, and for k is equal to 10, the system is stable. The option should be B. Polar plot can also be drawn in a different way, meaning you can find the magnitude and phase and start. Even you can do that, but that's all very time consuming. So remember, whenever there is zeros present in the numerator and there are n number of poles present, then the graph will be resembling like this. Suppose in case if you're having two, something like this, s plus 2 into s plus 3. So you will start at this point because there are zero zeros. One pole will be giving you minus 90 degree. One more pole will be giving you minus 90 degrees. So 2 into minus 90 degrees is 180 degrees. So your pole should be like this. It should end at minus 180. Sorry, your polar plot should be like this. These points, these magnitudes can be computed by putting in the values, plugging in the values. Omega is equal to 0. Those things can be done. This is at omega equal to infinity. But the plot can be visualized like this, because here, if you are consuming time in order to find the polar plot by calculating the magnitude and the phase, it will be a lot more time consuming in order to find what is happening in the plot. But that's not of our interest. We need to quickly draw the polar plot and find out what are the number of encirclements. So this is how it should be done. Understood? Is it clear with everyone? Is there anyone who has doubt in this? Yes, this is a previous year question. So
Can you quickly tell, means how to draw the table by seeing that equation? In the first case,
what is the table you're talking about? The route table.
yes.
Okay, so see. See, usually routes table should be drawn for. Okay, I'll come to your question, Sadat. 1 second. So usually a routes table should be drawn for the characteristic equation. What is characteristic equation? Characteristic equation is nothing but the denominator of the transfer function, closed loop transfer function, should be equated to 0. Okay, so here they have given, in the question, they have given only the information about transfer function. Usually, if it is a transfer function, Navier plots are drawn for open loop transfer function, if I'm right. Yeah. So here they have given an open loop transfer function. So now our interest is to draw the router, like formulate the router. How will you do that? It's quite simple. Suppose take like this: s power 4 plus s cube plus s square plus s power 1 plus s power 0 is equal to 0. Here, any coefficients can be missing as well. So, whenever you are given a question like a s power 4 plus b s cube plus c s square plus b is plus e s power 0, there should not be any missing powers. Means the powers should be continuous like this. It should be in the decremental order: 4 3 2 1 0. All the s terms with the power for like in the decrementing order of power should be present. Okay, if s square is not present, then you should write it as 0 s square. You should represent it like that. Okay, after that, take out the alternate terms. Take out the alternate coefficients. Sorry, a, c and e are alternate. B, D are alternate. Now quickly write the powers of S in the decrementing order. S power 4 is here, so S power 4, S cube, S square, S power 1, S power 0. Alternate S power 4 coefficient is A. The alternate even degree pass coefficient should be written here. S square C, E S power 0. Similarly, S cube, the highest degree is 3 now. It is an odd degree. So, coefficient corresponding to S cube is B. Then immediate alternate position is S power 1. It is also an odd degree. So, this is D. And here there's nothing. So, you here the coefficient can be written as AD minus BC by B. Similarly, A into 0, have it as 0, minus BE just a second. Okay, I guess I wrote it right. For sorry, I'm extremely sorry. So it should be confused the signs. Okay, it should be BC. Determinant will be taken in the different way. AD minus BC is what is determinant. It should be taken the opposite way. AD, BC minus AD divided by B is what is here. Similarly, BE minus A0 divided by BE minus A into 0 divided by B is what should be written here. Usually, when you have something like this, AE B0, or sorry, B C D E0, here some X term is there. Whenever there is a 0 below the E, something like this format is there, immediately this E will come here. Right?
Yes.
This, yeah, the same thing will be going on like this. So here again, this 2 you will multiply minus this 2 divided by this. That coefficient will be written here. Here there will be nothing because 0 is here, so 0 you will put. So here again, this term will come here because there is a 0 here. This term will be coming here. So like this you will fill this full array, the complete array will be filled, and you need to check whether the first row, first column is all positive or is there any sign changes. So if there are sign changes, if suppose if A is greater than 0, that is plus, B is less than 0, minus, if this is term is plus, 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 if there are two sign changes, that means there are two open loop poles or two poles which is corresponding to the equation, like if you're taking the characteristic equation of a open loop transfer function that is given here, that much number of poles, open loop poles or closed loop poles will be present in the right half of S-plane. For example, in this, we used the route array to compute the number of open loop poles falling in the right half of S-plane, right? So we found there are 0 poles like falling in the right half of S-plane through what? Through finding the number of sign changes in the first column. So similarly, if there are two sign changes, right? So there are two poles in right half of S-plane.
Sure, thank you. Understood completely. Thank you.
Yeah. Okay. So Sadak, coming back to your doubt. So n is equal to -2. Why is n is equal to -2? Okay. See, they have told that they have never told something like there are two encirclements, something like that. They have never told in the question. What they told is that b is equal to at k equal to 100, the number of encirclements is present. Okay. So here, only when -1 comma 0 is present inside the circle, like inside the plot, only then you can find the number of encirclements. For k equal to 10, this -1 comma 0 is outside the Niger's plot, which implies that there are no encirclements. For k equal to 100, the b should be inside the plot such that there is encirclement. It is given in the question. It is given in the question. For k equal to 10, does not encircle the point. It does encircle the point. But how many encirclements we need to find out? So this is a shortcut. If you are like finding out how many encirclements are there, draw slanting line such that it covers the total Niger's plot. Okay. Now the arrow marks are going something like this. Usually omega equal to 0 to omega equal to infinity is the direction of the arrow marks. So this arrow mark is going like this. Similarly, it goes like this and it goes like this and it goes like this and completes the plot. So if there are two arrow marks which are approaching the slanting line, that means n is equal to 2. If suppose, for example, if this arrow mark is something like this, it is going out and this is coming in. So this one cancels with this. So we get the encirclement as 0. If suppose something like this happens. But for us, the case is like this. So n is equal to 2 is confirmed. But we need to note whether it is a positive or negative sign. That's why I given a note before. If it is an anti-clockwise, if the encirclement is anti-clockwise, then n is positive. If the encirclement is clockwise, then n is negative. So in that case, here, what is the direction of this? We know this is a clockwise direction. This is also a clockwise direction. So n should be equal to -2. Got it, Sadat? Is it understandable? Sadat, are you there? Okay. So we are concluding a session with these two questions. I want your feedback on this session. So whether that
Hello.
yeah.
Yeah, I want to know that at last, for concluding our problem, we approached a formula saying z equal to p minus n, right? And means to know how number of open loop poles in right hand side of S plane. And for p and z, you told the same. Is there any difference? Means z
Oh,
is
did I? Okay. See, P is nothing but the number of open loop poles in the right half of S plane. Z is the number of closed loop poles in the right half of S plane. What is closed loop poles? Because we for stability, where we can, what we are going to talk about? We are going to talk about the poles of the closed loop transfer function, right? So here, I guess I confused. Okay, so here it should be like by principle of argument, z is equal to p minus n. P is the number of open loop holes. Z is equal to p minus n. We know that p is equal to 0 from before a route array, formulating route array and all. And just now we saw n is equal to minus 2. So z should be equal to 2. What is z? Z is the number of closed loop poles in right half of S plane. So two closed loop poles are in right half of S plane. That means it shows that the number of poles in the right half of S plane will lead to the unstability. Okay, I denoted P here. Sorry for that. It should not be P. It should be Z. Z is where we need to see for stability when it comes to Niger's plot. P is the number of open loop poles. Z is nothing but the number of closed loop poles which are in the right half of the spring. Yeah, we can do that. Yes, we can do that. You can formulate the characteristic equation and compute the values of range of k such that the system is stable. That approach is right. Yes, the recording will be made available in the gate portal wherever you have clicked the
Okay.
link, right?
No, for case 2 actually, for case 2 at the end, we must see whether we have closed loop poles at the right hand side to check the stability, right? So
Yeah.
in case 2 at the end we have written p is equal to z minus n. We came to know about n by drawing that, that's fine. But how about p in that case?
We did it before, right? Because we are plotting for the same Niger's plot. Like, sorry, for the same transfer function.
I
So
mean,
we
k
got to know.
doesn't make any sense. I mean, any number of k is it is generic one for k equal to.
Yeah. That's what I said. K here doesn't make any change when it comes to route array, but when it comes to n, anyway, this z is depending on n as well, right? The encirclements. So that is part of the question which they have given.
Sure, got it.
Yeah, if you're like, usually they do this route array for a closed loop transfer function. That's what you have read in control systems. When you formulate a characteristic equation out of control, like closed loop transfer function, you will be drawing those, writing those values in the route array and formulating the full table and finding out how many changes such that how many poles lying in the right of a sprint. That's how you do. Here, that is of separate concern, but they have told that the number of encirclements is so and so for k equal to 100 and k equal to 10. Like k equal to 10, they have generalized that there are no encirclements. For k equal to 100, there is an encirclement. So from that, usually Niger's plots are drawn for open loop transfer function. So they have given that using that shortcut, I do the open loop, polar plots and Niger's plots, and finally got some plot. Now it's our turn to see whether B should be lying inside. I mean, minus 1 comma 0 should be lying inside or outside depending on the value of k. Right. So that's how we have proceeded here. There is no point of k, like there is no significance of k in finding the number of open loop poles in right of this plane. However, the encirclements are playing a role here. That's why there's a difference in computing the number of right of this plane. So number of poles in the right of this plane. Understood, Rajat? Is it
Yes,
fine?
sure, sure, understood completely. Thank you.
Yeah, good. So, ma'am, we can also find the stability based on sign changes. There are no sign changes. Otherwise, the system is unstable. We can also find number of poles based on number of sign changes. See, that's all like one way, but here they have given only open loop transfer function.
Hi, ma'am.
So, yes, I couldn't hear you. Hello, hello. So here they have given only the open loop transfer function. So out of that, you can't say how many number of closed loop poles are present. That can't be said. Ma'am, I'm studying in first year. Is it right or any classes? This class is here. Control system is kind of a third year subject, I guess, fifth semester subject. Uh, First year is too early to start, as far as I know. But if you're like getting insights from this class, just make notes. If you're like free, you can just come over and attend the class and make notes. And when you're coming to third year, or if you're like over interested, and if you're starting control systems prayer in well advance, uh, well in advance, then I think that this kind of preparations will help you. But before that, you need to know a lot. Means like Nyquist plots, you know, need to know. Polar plots, you need to know. I think it's too early. You'll get afraid once you see these. So better to start like a second year mid or some time for this control systems. Other than that, signals and systems, networks and all, it's like an elementary subject which you can start in first year itself. Control systems, you can take time to study for gate. Anyway, you can appear for gate nowadays in third year also, right? So a proper uh, planning for control systems can be done in the end of second year or in the start of first year. Although you have, if you have to give an attempt for at in third year, then you can start in second year for control systems. Otherwise, like first year is too early. You can go through digital electronics, networks, even signals and systems at this time. If you're over interested, you can even start studying Nigus plot. But this platform, like this program, is not completely teaching basic things about control systems or signals and systems. It's about solving the questions in 1 hour and helping the people who are going to appear for exam in the upcoming GATE 2023. So, yeah, this is the answer for your question, Gopika. Yeah, thank you. So is this pace okay with you all, or is there any feedback for this particular class which you can like put up in the chat box for me to read and come back for the next week? Or is the pace okay? I don't. Okay, there's a discussion forum separately for this. However, the questions which I plan itself will not be sufficient for 1 hour. So you can post these questions in the discussion forum. There will be a discussion forum available in the Gate NPTEL portal itself. Okay, okay. I'm not sure how, because the motto of the class is to make all the students who are attending the class at least to understand by 75%. That's what my motive is. It's not like brightening up the bright minds. It's not about. It's not like that. It's to help the like average student also. That's why like the pace is quite slow. Otherwise, I will be rushing it. That's no problem with me. But the students should understand. So that kind of acknowledgement from the students is very much necessary for me. So I'll try Utkarsh to increase the pace by a little bit. Any other suggestions and feedback?
Yeah,
Are you?
I have one
Yeah,
question. Can you share your screen?
yeah,
It's
sure.
about the route array.
Yeah. Others can leave if you're not having any doubts. The class is over. Yes.
Yeah.
Yeah.
So the route table is for open loop system or closed loop system? Mm.
See, a route array, as far as I know, usually it will be drawn for stability analysis, for closed loop transfer function, like for characteristic equation of a transfer function. Usually, wherever I have seen, it is like you just write the characteristic equation and formulate the array and find out how many poles are lying in the right off of S-plane. So it can be like formulated for verifying for both open loop transfer function and closed loop transfer function. Unless like you can formulate that characteristic equation, and out of that you can write the so and so coefficients. It will be done for both, but mainly to find the stability of a system. For that, we use the characteristic equation.
So here you have written it for open loop or closed loop. It looks like
Yeah, this is open loop transfer function. For that, this is
why
see
is there the K?
they have not given that it is a unity feedback system, right? So only when it is a unity feedback system, you'll be like adding the numerator and denominator and form, and you say that this is a characteristic equation of the closed loop transfer function. Here, nothing like that is given. They are given a transfer function. For that, you are formulating a characteristic equation and finding out formulating the router and finding out how many poles are lying in the right of a spring. So in this case, we are writing it for open loop transfer function, not for closed loop transfer function.
Okay,
When you when
there
you
should
say it
not
is,
be a
yeah,
K, right?
yeah.
There
What's that?
should not be a K in the route table, right?
There should not be a key in the roster. Okay, what they have given, the Nyquist plot of the transfer function g of s is equal to k by s square plus 2s plus 2 plus plus 2. So they say it's the open loop transfer function. We can use trans. Okay, if that is so, if we are like taking in the denominator and equating it to 0, yes, there should not be a k. Yes, it should not. There should not be a k. Only when we say it is a unity feedback system. Sorry for this. There should not be a k.
Yeah.
Before, I guess I wrote it rightly. Yeah. So here it should be 0. Yeah. So yeah, correct. So usually when they give it as a unity feedback, then you need to add the numerator and denominator and formulate it as a characteristic equation. Now they have themselves given it as a transfer function. So the denominator will be the characteristic equation of this particular open loop transfer function. Yeah, you're right, Sadik.
Yeah. Thank you.
So yeah. Okay. Sadik, is the pace okay with you?
Yeah, yeah, it's okay.
Or it should be a little more fast?
It's okay. Probably after
Yeah.
3 classes, we'll increase it. Yeah.
Yes, yes. Okay. Okay, thank you for joining.
Thank you.
Bye. Bye. This session will be anyway available in the portal. So the live recording will be available. Thank you.